In this video, we are going to go over the following user fatal messages or UFMs. We are going to go over user fatal message 9050. We are going to go over UFM 10030 and UFM 10031. Now, there are many causes for these UFMs. I'm going to go over a very common one. I'm going to go over the cause, one of the causes, and a possible fix. This is the finite element model we are working with today. Basically, you can think of this as a cantilever beam. One side of this beam is fixed, and on the other side, the free edge, or the free side, we apply a force at this corner, like you see here. When we look at this mesh, it looks like everything is connected together. This message sometimes happens, or commonly happens, when a piece of the mesh is not attached. So here, this is what you would do in Apex. You would right click on the model, and then you would place it in the analysis scene, and you would run what's called a normal modes analysis. So here at the bottom, I've selected normal modes Sol 103, and then you click this running man icon to start the analysis. Now, I've already done this, so maybe we'll just go ahead and look at those results. Now, there is an engineering purpose for a normal modes analysis. There is also a debugging purpose for normal modes. It's actually useful to identify pieces of the mesh that are not attached to each other. Now, when you open or look at the results, you get multiple mode shapes. Now, here at this horizontal bar are all the mode shapes. Right now, they are being ordered in increasing natural frequency. So here at the far left, if I click this vertical bar, it's showing me a mode shape that has a natural frequency that's close to 0 Hertz. Here on the far right, I have natural frequencies that are about 36.3 Hertz, and then maybe a little higher, something like 40 Hertz in this next vertical bar. There is an alternative way to look at these modes. Here at the bottom left, if you click this second button, mode number, this orders the modes by mode number. So here on the far left, we have mode 1. Here, let's go ahead and hover over this vertical bar. So this is mode 1. You can click the individual vertical bars, but I like using this other button. Step forward here on the bottom left, and this will let you jump along the different mode shapes. So here we go to the first mode, mode 1, and then here in the bottom center, click play. And then you can control the speed of the animation with this slider here. When you click animate or click play on this, this shows you what the first mode looks like. If we go to mode 2, mode 3, it's very clear that this vertical section in the mesh is not attached to the rest of the structure. This is what we have to fix. The fact that this piece of the mesh is not fully supported, the fact that our equilibrium equations, the sum of the forces in the x, the y, the sum of the moments in the x, the y, and the z, the fact that the equilibrium equations are not satisfied gives us this error. That's a problem for us. We either need to support this piece of the mesh, or we need to make sure that it's attached to the rest of the mesh. You know something is not attached when the natural frequency is very small and close to 0. Here at the bottom left, if you look at the natural frequencies, you have 3 times 10 to the negative 4 Hertz. To the negative 4, it's very small. It's effectively 0. If you go to the next mode, same thing. It's 2 times 10 to the negative 4. Here in the bottom right, you have this table icon. If you click that, you actually get a table of the modes and the respective mode shapes. So here, let's go ahead and see if we can go to that. So here you can see the listing of the 10 modes and the corresponding natural frequencies. Here you can see that the first 6 modes have a very small natural frequency. This one's a 3.3 times 10 to the negative 4. This one's 9.87 times 10 to the negative 5. And then the 6th mode is 2.44 times 10 to the negative 4. Now, let's exit the results. Let's now talk about how to fix this. I came up with a very simple way to determine if you're going to have a detached mesh or not. When you look at the geometry in MSC Apex, or on most products, I believe, most software tools, they will show you different colors of the edges. If the edge is ever red, that means you have a detached or unattached geometry. That's going to give you that disconnected mesh. So here we look at this very closely. If you look at this edge, it's red. So it's detached from the rest of the geometry. If you look at the bottom also, it's the same thing. Here it's red, so it's detached from the rest of the geometry. Here in the center, it's the same thing. Here at the bottom, even though this edge is right on the surface, the edge is still red. That tells us that this geometry is not connected to this other piece of geometry. And then the same thing is true for the top. Just because the edge is right on the surface, it doesn't mean it's attached. You have to make sure that this red edge is either green or yellow. Now here on the right is what a attached geometry looks like. Not only is the edge on the surface, but the edge is now yellow. If you look at the bottom, same thing. The edge is now yellow. So basically, to sum this up, red is bad, yellow is good, green is also good. So again, red is bad, green and yellow is good. So now let's go ahead and go back to Apex. Let's go ahead and maybe hide the mesh. So let's go ahead and right click these meshes and let's go ahead and hide them. Now, let me take a step back and look at the mesh. When you look at the mesh, it looks like everything is fully attached. But here in the vertical bar tools at the top, there's this button, Geometry Visualization. You can click on this option, Topology Lines of Visibility. This will show you the green, the yellow, and the red colors for the edges. So here we have green. We have this green edge. That means these two different faces that are orthogonal to each other, they're attached at this edge. If you look at this other edge, this edge here, it's red. So even though it looks like they're attached, the red edge is telling us that they're not really attached. Now for this bottom piece, it's more noticeable. You can see that we have a red edge here, and there's actually a gap between this edge and this other surface that we have here. So these are the errors that we have to correct now. So let's go ahead and do this. Let's go ahead and hide the meshes. One of the things you want to do, you want to make sure that all the faces that you want to be attached, make sure that they're all in one part. So right now you see that surface 4 is in its own part. What we're going to do is now take that surface 4, we're going to left click and hold, we're going to move it to part 2. And now that surface is in the same part as the other surface. So all these surfaces are in the same part. Now let's go ahead and talk about how to fix these issues. So we'll open the geometry edit tools and we'll go to vertex edge drag. So we'll zoom in and we'll simply take this edge and we'll drag it. You see how I'm left clicking and holding that edge, and I can move it almost anywhere that I want. Here I'll move it until the surface turns orange. This is telling the program, hey, just drag that edge up to that surface and then let go. And then this is going to go ahead and perform a bunch of operations automatically. And now you see that edge is yellow. So this surface is now attached to the rest of the surface that you see here. Now what about the top? Let's go ahead and see what happens at the top. Let's undo that action. you can see that this edge was already at the surface, but after we drag the other edge, so let me jump forward a step, it automatically stitched that edge to the other surface. So here, let's manually stitch these surfaces actually. So let's jump to this new tool. At this point, you're done with this operation, but I'm going to take it another step and talk about stitching. So we'll click on stitching now. We are going to click on this geometry, or this button called Unstitch Geometry. We'll click this face, press the middle mouse button, and now that geometry has been unstitched. Look what happens when it's been unstitched. The edges are now red. And now this is very subtle. Here what you see is that it's green sometimes and then it's red sometimes. So I'll explain what's happening here in a moment. So again, what unstitch did, it broke apart this surface from the rest of the geometry. So you can see that the edge is now red. Sometimes when you rotate the model or you zoom in, it turns green. Why is it turning green? Let me hide that surface for a quick moment. It's green because these two faces are attached. And then if I hide and show this other surface, you can see that this edge is red. It's now detached from the rest of the model. So let me go ahead and show all of these together, and let me do this. Let me take it a step back actually, so it's a little bit more clear. So let's go ahead and undo that drag. Okay, so here I've gone back a few steps, so we have that gap that was there before. Let me show you what stitching does. So here back on the right in the stitching tool, we'll select the stitch geometry option. So this edge here, again, is not attached to these surfaces. So what I do is I select all these surfaces, then I click the middle mouse button. It then takes this edge and it stitches it to the rest of the surfaces. So now you can see that it's yellow. It's green when you have two surfaces at the edge. It's yellow when you have 3 or more edges attached. So here, if you count the surfaces, we have one surface, and another surface. You stitch them together, you have 3 or more edges, or you have 3 or more surfaces at this edge, so it's yellow, not green. Now, what about the bottom? The stitching worked because the gap between the edge and the surface was almost 0. Here, the gap is a lot bigger. So the algorithm saw, hey, this gap is too wide, so I'm not going to stitch. What you can do, you can modify the stitching tolerance. Basically here, you would make this tolerance big enough for the gap, and then it would stitch this gap together. Alternatively, you can use the vertex edge drag option. Now, the vertex edge drag option, it also works with vertices. So here I took that vertex and I dragged it to that edge, and then I'll do that same action here on the left. And then here you can see that it's stitched the geometry here also. So again, a red edge is bad. If you have a red edge, that's detached geometry. If it's yellow or green, that means the geometry is attached. So the mesh will be attached at that junction or interface. Now, here you can see that we have red edges here at the free side, or rather on the right side and the left side of the geometry. This is okay. You can see that there's no more geometry here on the left. There's no more geometry on the right. So it's okay to have a red edge there. There's no other geometry to connect to. So here on the left and the right, it's okay to have red, but here in the middle, red is bad. In the middle, red is bad. You want green or yellow, like you have here on the screen now. So let's go ahead and throw a mesh on this. And one other thing, always save. So here, let's go ahead and save. Typically, I like to save every 10 or 15 minutes, just in case something happens. We have to abort. So here, what I'm going to do on the left-hand side, we're going to right-click on the model. We're going to go to Export, and we're going to select the Parasolid Geometry option with X T at the end. And we'll go ahead and call this geometry backup 2025, today's date essentially, and then we'll go ahead and give this time. So here we've exported the geometry. So if I ever need to get a backup of the geometry, if I ever want to go to a separate CAD program, I have the geometry available that I can use. So now what I can do, I can go ahead and now start a new normal modes analysis. Or before that, let's go ahead and make sure I have a mesh on this. So again, a normal modes analysis would be good for debugging. Like I mentioned earlier, there is an engineering purpose for a normal modes analysis, but it's also very useful for debugging a finite element model. It helps you identify whether or not there are detached parts or meshes in your model. So here I have a mesh. Let's go ahead and now run a normal modes analysis. So let's go ahead and switch to normal modes, and let's go ahead and click the running man icon. So this does take a while, so what I'm going to do is I'm just going to pause the video here and just wait for this to finish. Now we're almost at the end of the simulation. Let's go ahead and open the results. Now while this is happening, that ability to move a vertex or an edge, let me make sure I'm looking at the right results here. Oh, okay, we're looking at this in split view. Okay, so let me just look at the results, then I'll get back to the point I made a moment ago. So here on the left was the original problematic model. Because we had the red edges, the geometry was not attached. Since the geometry was not attached, the mesh was not attached. We had these 0 hertz mode shapes. So if we look at these animations, let's see if we can do that. Here was mode 1, mode 2, mode 3. It was very clear to us where the geometry was not attached. Here on the right, let me pause the animation here on the left. Okay, this is taking a while. Let's go ahead and give it time. Okay, let's go ahead and jump to the right. Here on the right, we're going to do the same thing. We're going to animate modes 1 through 10 and just see what's going on. So here I've selected the window on the right. Here you can see that the border is orange or yellow, so I'm actively modifying animation settings for the right window. We'll go ahead and click on play, and then the speed of the animation is too fast, so here at the bottom center, we'll go ahead and move the slider a little to the left. This will go ahead and calm the animation down a little. A moment ago I was a little excited. Okay, now here, let's go ahead and look at the mode shape. So you see this center or vertical section. The animation is suggesting that this centerpiece is now attached to the rest of the mesh. This is good for us. Right now, I believe we are looking at mode 1. Let's look at mode 2. Okay, things look good so far. Mode 3, mode 4, mode 5. Typically, the 0 hertz mode shapes, they're within the first 6 modes. Up here, instead of going through all these different modes, I'm just going to open the table. If we look at the modes are non-zero. Here we have 95.9 hertz, 106 hertz, 118 hertz. Before we were getting something on the order of 1 times 10 to negative 4, 1 times 10 to negative 5. The exponent was very, very small, negative 4, negative 5. If it's negative 8, negative 12, they are effectively 0. If they're 0 hertz or nearly 0 hertz, you have a rigid body mode. That's what these are called. Here on the left, those floating pieces, that's a rigid body mode. What this error is saying here, it talks about a mechanism, a rigid body mode. A mechanism and a rigid body mode, what that means is that your deformable body, it's allowed to move with no deformation. It's a mechanism. So here on the left, this piece, since it's not attached, it's not supported, it's able to just move without deforming. That's what's causing the problem. More specifically, the stiffness matrix, you cannot find the inverse of the stiffness matrix. But here on the right, what we did is we made sure we had green or yellow edges. We made sure that the centerpiece is attached to the rest of the geometry. We did a confirmation analysis, and now that piece is fully attached. So now what can we do now? We can now configure a solution 101 or a linear statics analysis, knowing that the mesh is good to go. Now here on the left, let me export the geometry. So we'll go ahead and repeat the process. You might be using a different program. So at the end, maybe you want to continue the work in a separate program. So this is why we need the geometry to be exported. So here, that's what I'm doing right now. So we export the geometry. If you look at the bottom left, we get the status, exported the geometry to this directory. Now, let me quickly summarize what was going on here. We saw that our geometry was actually detached. And then I went over this story of the red edges. Remember, the red edges are bad. If you see that, the geometry is unattached, it's detached. If you ever see green or yellow, that means good. That means the geometry is attached to itself at that edge, if you will. We went through this process of manually moving the edges with vertex edge drag. We moved some of the vertices with vertex edge drag. We went through the stitching tool also, so you can see the different ways we can combine the edges together. Now, I recommend using MSC Apex whenever you want to move an edge or a vertex. I say this because in a lot of other tools, it takes a long time to simply move one edge, but you saw in this video that it was very simple for me to move the edges and the vertices. I recommend using Apex to create your mesh, to modify your geometry. I also recommend using Apex to set up your analysis, but that's okay. If you're required to perform the analysis elsewhere, if you're required to configure the analysis elsewhere, that's okay. Right click on the geometry, export the geometry, then move over to that other program and import the geometry. So here you can see what the geometry looks like. It's a bunch of parasolid files. This geometry has the corrected geometry. Now when you go to a separate program and you mesh that geometry, the mesh will be fully attached. Now we're at the end of the video. The goal of this video was to discuss how to fix these UFMs 9050 and UFM 10030 and 10031. These are some of the most common errors you'll find when you're working with Nastran. This was just one possible error. Again, this error happens because of some of the forces. So I'll say sigma fx. If you recall from a statics class, the sum of the forces in the y, the z, this should all be 0. The sum of the moments about the x, the y, and the z, they should all be 0. If at any time one of these equilibrium equations is not true, say, I don't know, maybe something is equal to non-zero, maybe 10 as an example, you will get that 0 hertz natural frequency. You'll get that floating piece like you saw a moment ago. So the solution is either to make sure you have green or yellow edges. Make sure you have enough supports. So make sure you have enough supports to satisfy these equilibrium equations. In a more complicated scenario, it's okay to have detached meshes, but you would need to connect them with each other. So in some cases, you will use fasteners, rivets, bolts, C-bush, RBEs, etc., etc. Or you can use something that's called permanent glue. Fasteners and permanent glue, that is outside of the scope of this video. So the easier approach, just in case you're new, just make sure the edges are yellow and green. Another example when you might get this error, I believe, might be when you haven't supplied material properties enough. So maybe your Young's modulus, if you're dealing with the composite, your Young's modulus for the 1 and 2 directions, if that's ever missing, this sometimes happens. Also, I believe if the thickness is too small, so suppose that your thickness is 0.1 meters, but you've accidentally typed it in as something very, very small, so something like that, this will also give you these UFMs, I believe. So like I said, this is a very common error for new users. You saw that there was a very simple way to fix this. Just make sure the edges are green or yellow. Red is bad, green and yellow are good. So just make sure everything is attached to each other. These UFMs have many causes, but I think this is one of the major causes. The detach or unattached mesh is one of the most common reasons, so that's why I wanted to create this video for you. Okay then, now just in case you have feedback on the video, you can contact me at this email address. So if the audio was not that good or the video was confusing, I'm always open to feedback. If you have a question, feel free to email me at this address and I'll try to get back to you as soon as possible. So with that, I'll stop here, and as always, thank you so much for watching.